so section 1.5 on graphs. Right, so remember last time we were talking about having two dimensions. Right? We have two dimensions, right? And we can put, we can call the variables x and y, right? And we can have expressions now in either variable, either or both variables. Right? You could have things like x squared, you could have y squared, you could have xy, you could have things involving either or both variables. And so we can have equations involving two variables, right? So you could have like x equals y, x plus 2 equals y squared, right? This sort of thing. Okay, so yeah, that's not shocking. Okay, and so the game changes slightly, right? So the game changes just a little bit, slightly. Right, where before we were looking for the x that solved the equation, now we're looking for x's and y's, right? So looking now for, the game is now defined pairs of points x and y that satisfy the equation. Right, the solution set is now collections of pairs of points. Okay. Okay, and then so basically this is just a list, right? The solution is going to be some list, right? So if I say this is my equation, then you can give me a list of points that satisfies this, right? What's the solution set to this guy? X equals y. Well, what would the solutions look like? So, for the equation x equals y, the solution set is what? What does it look like? Just pairs of points, right? Things that look like x, y, where x equals y. Right? Things like, can people give me examples? It's too silly a question, too easy a question. Lauren?
Yeah, 1,
1 comma 1, right? 2 comma 2. Anything where the first and second variables are the same, right? It's anything, to write it more simply, it's anything that looks like AA, say, where A is any number. Right? That's maybe a more clean way to write it. Right? Anything like this, anything AA where A can be any number. Right? And this is how you write it this is how you express it as a set, right? And then, just like we had in one dimension, we had a way of representing the solution set on the number line, right? We are going to do the same thing. We're going to have a graphical representation of this on the plane, right? So we have these things called graphs, right? So the graph of the solution set, graphs. So we go like this. We represent the solution set graphically by creating this thing called a graph, right? By defining, say, a graph. And the graph is, of course, given by some rule where xy is on the graph whenever, if and only if, I'm sorry, let me make a fixed point. X naught, y naught is on the graph, if and only if the pair x naught, y naught satisfies the equation. Right? So this probably seems sort of pedantic, right? You all know what a graph, is, but this is how you define it, right? The graph is all points where the pairs satisfy the equation, right? So if we're looking, we have the solution set here, we want to represent it graphically, and we say, okay, well, that's going to be all points where the x and y coordinates are the same, so it's going to be all points, all points like this, right? All points along this line. Right, this thing is the graph of the solution set of x equals 1. The graph of the solution set of x equals 1. And people usually just say the graph of x equals 1. Right? It's the graph of the solution set. Right? So appearing on the graph means that you solve the equation. Solving the equation means that you will appear on the graph. That's what this double arrow means. Appearing on the graph in plot means that you solve the equation. Solving the equation means that you'll be on the graph. It's a logically equivalent statement. For example, this morning I was thinking, I saw, like in my ham, I eat ham sandwiches in the morning. On the package of the ham, it said, like, no fat. And I was thinking, does no fat, maybe like no fat implies no flavor. But no flavor doesn't imply no fat. Right? So like, these are not logically, anyway.
Ham sandwiches in the morning?
Well, just a small piece of ham. Okay. Okay, so, for example, right, if I say something like 2x equals y, right, or if I say something like x squared equals y squared equals 1, right, then you can create graphs. I'm pretty sure you all can create graphs of the solution sets of these equations. Maybe just take 20 seconds and sketch out something. Right? So what's the first one look like? And what does the first one look like? Graph of intercept.
It's a linear slope that just goes up and
It's a line, right? It's a line. We actually haven't done lines yet, but I'm sure you've seen them. Right? This is going to be a line where the slope is 2. Right? A line where the slope is 2. If you don't want to think about it that way, you can say, well, it's going to be anything in the form x1. It's going to be anything in the form of AB, where B is 2 times A, right? B is 2 times A, and then this A2. Right? The y coordinate has to be twice the x coordinate.
You mean 2B, not 2A, right?
No, anything. The y coordinate should be twice the x coordinate.
Oh, I see, okay.
So that A is the x coordinate, 2A is the
It's slow piece.
So, right, so the y coordinate is always going to be double the x coordinate. Right? So here's the x coordinate, then this must be the y. Here's the x coordinate, then this must be the y. If that makes sense, right? You see what it looks like this. Right? And the second one, what is it? It's a circle, right? It's a circle centered at the origin. Again, we haven't done circles, but we'll do them shortly. It's a circle around the origin, radius 1. We'll do it maybe even this class. No, we won't. We'll do it next class. But anyway, the point is that you create this thing called a graph, which is a representation of the solution set. Continuing, what is undoubtedly a review for you. We have this notion of the x-intercept. Points called x-intercepts, right? what are those? You know, calling it already. It's going to be, you have the graph, the x-intercepts are where what happens?
Y equals 0.
For y equals 0, where you intercept the x-axis, right? So where the graph points where the graph intercepts or intersects the y-axis, the x-axis. Was that knocking just now?
Yeah.
Okay. Points where the graph intersects the y-axis, right? And that's points on the graph, with y coordinate 0. Right? Points on the graph with y coordinate 0. This one y coordinate 0. This one intersecting the x-axis. Right? And I'm pretty sure you all know how to find x-intercepts. And then similarly for y-intercepts. Right? And I'm pretty sure you all know how to find these sorts of things. Close your eyes for a second. Does anyone want me to do some examples of this? Okay. Open your eyes, please. Thank you. So we'll do a couple of examples. If I give you something like this, 3x plus 2y equals 5, and I say find the x and y intercepts of this thing, well, then the game is you have to find the guys who solve it. To find the x-intercepts, you say, okay, right, so to find the x-intercepts, that's the points, to be really laborious about this, it's the points solving the equation when y is 0, right? So I look at 3x plus 2y equals 5, and I set y equal to 0. Okay. Set y equal to 0. Right. 3x equals 5, so x is going to be 5/3. Right. So I know the point 5/3 comma 0 is an x-intercept. And then similarly for y-intercepts, I say, well, that's the points to solve the equation, right? I should give the implication here, right? This implies this implies this. If y equals 0, then okay. If I'm talking about the y-intercepts, then I say, okay, well, I want the points where x is equal to 0. The points that solve the equation, right? The points that satisfy the equation where x is 0, right? So I'm looking at 2y equals 5, y-intercepts, right? Where 2y equals 5, right? So y equals 5/2, right? And so the y-intercepts then are just 0, 5/2. So maybe just take 1 second and do this one. Let's see. Find the x and y intercepts of this 1 minus 3, x squared plus 1. Find x and y intercepts. So maybe turn to somebody next to you and say something.
But then you can't sort of remember that. You can't square root a negative number, right?
Right. So
So,
actually some of them,
what do you do?
one of them won't have any, one of them won't intercept.
So it's just non-definable?
Yeah, there's no, maybe, you could have a graph like this, say, right? In that case, it's not going to, you wouldn't have any, y-intercept. I think that's basically what's going on here. Okay, yes.
So it can't be like 2i. It can't be the x, can't be like 5.
Okay, so in this course, we're not going to use imaginary numbers. So in the real numbers, there is no intercept. But so let's do it. Right. So how do you find the x-intercepts? Well, you set y equals 0. Right, so x-intercepts. Right. You set y equals 0. Right, and then you get that negative 3 equals x squared plus 1, whether it's x squared is equal to negative 4. Right? Right. And in the reals, there's no such thing, and that doesn't happen. Right? So no x-intercept. Right. And for the y-intercept, you set x equal to 0. Right? X equals 0. And so you see that y then has to be 4, right? So 0 to 4 is the x-intercept. Right? 0 to 4 is the x-intercept. And those of you who know about this, what is this actually? What does the graph look like? Those of you who've taken Precalculus before. Y is equal to, what's the graph of this thing? It's a parabola. Shifted up by 4, right? That's the picture, and that's why there is no x-intercept. Okay. Okay. Well, anyway, finding it's a very simple notion, right? X-intercept, y-intercept. Where does it intersect? What points? Does it have any solutions when x equals 0? Does it have any solutions when y equals 0? Okay. Okay. Continue onwards, again with more sort of review stuff. Equations of lines. Equations of lines. So I think I'm just going to say this. Let's recall that I think you all probably saw this in junior high school. So let's recall that equations describing lines have various forms. Right? Like how do you describe a line? Y equals mx plus b, right? That's the popular slope-intercept form. Slope-intercept form. Are there other forms that people recall?
Standard.
What's standard?
Ax plus by equals c.
Okay, so the standard, or I think in this book they call it the general form. General form, ax plus by equals c. Right. And that's good because that can, you could use that to describe a vertical line, right? A vertical line where x is equal to some number, say, right? And you notice that that you can't do that with the y equals mx plus b form, right? You can't describe the vertical line with the y equals mx plus b form, right? Because the slope would have to be infinity, right? To be vertical, you'd have to have m equal to infinity. So there's some restrictions. This is more general, and that's why it's called the general form. This is more general than the slope-intercept form. It can encompass more things than this thing. Okay. There's another form called the point slope form. Have you ever seen that? Point slope? I think I'm going to say that you all have seen it. Point slope form, which is this: y minus y naught equals m x minus x naught. And so these are all ways of describing lines, and it turns out that using basic operations, all can be transformed into the general form. Right? If somebody gives you one in the point slope form, well, you can change it into the general form. If somebody gives you in the slope-intercept form, they can change it into the general form. But like we just said, the opposite is not true. Right? You could have something in the general form that is a vertical line, and then there's no way to describe it using these other two forms. So the general form includes all lines, and this one, these two guys, only lines that are not vertical. All lines except for the vertical ones. Let me show you what I mean by this. If I say somebody gives you the point slope form, right? And then you can transfer it to the general form just by elementary arithmetic, of course. Right? You say, well, look, this is 2x minus 4. Right? This is the same thing as that. This is the same thing as y minus 2x is equal to minus 1. Right? And now it's in the general form. So that's not remarkable. You should be rolling your eyes. So don't roll your eyes. I visited my younger brother recently, and I rolled my eyes about something he was saying. It angered him way more. Okay. Okay. So nothing amazing. Right. Oh, so I make another comment. Like you can change, if you have something in point slope form, you can change it to slope intercept form, right? That's easy, right? Because be like, well, just to give a concrete example, y minus 3 equals 2x plus 2x minus 2 to the same one, and we'll change it into slope-intercept form, right? Well, all we want is the y on the left-hand side, right? So we get 2x minus 4 plus 3, so y is equal to 2x minus 1. And this is the slope-intercept form. Okay. So the point is that all these forms are basically the same. Roughly speaking, they're all the same. And the general is slightly more general. But basically, if you have one, you can switch it to the others. So you might, the question you should ask is, what's the point of having these three different forms? And the point is that each one just emphasizes a different aspect, right? Each one emphasizes different aspects of the line, right? This one, if you say y equals mx plus b, right? Then you know, right? Then you know that the slope is m, and then that the y-intercept is b, right? Right? That the y-intercept is b. If somebody gives you something in the point slope form, well, you know, what do you know? You know that the slope is m, and then you know that you don't know. You do know. You do know. You should know. What is it? What information does this give you? It gives you one solution immediately. What's the solution?
A point on the line.
It gives you a point on the line. It says that x naught, y naught satisfies the equation, right? Look, if somebody gives you this thing, you say, oh look, it's in point slope form. I immediately see that if I let x equal 2 and y equal 3, then I have a solution. Right? So this one gives the slope and y-intercept. This one gives the slope and one solution, one particular solution. Okay. And then, well, this one is just sort of the general one. Okay. But if, for example, if somebody gives you, says, here's the slope of the line and the y-intercept, well, then it's easiest to put it in this one. If somebody gives you a point, if you find a point on the line and the slope, then you put it in this one. It's just whichever one is most convenient to you. Okay. So, example, right? If somebody says, I know that the slope, I give you a line and it passes through 0, 5 and has a slope of 6, has a slope of 6, well then you can write down the equation for the line, right? And take 5 seconds and write it down. 1, 2, 3, 4, 5. Right? What is it?
1 minus 5 equals 6 times x minus 0.
1 minus 5 is 6 times x minus 0. Right? By using the point slope form. Why? Right? If you're given a specific point, x naught, y naught, right? Then you can use this form to write it down. Right? 1 minus 5 equals 6, x minus 0. Right? Here is the point 0, 5, right? And here's the slope of 6. Like this is your m, this is your x naught, and this is your y naught. Right? If somebody gives you somebody says the line is vertical and it passes through 3, 2, right? Well, how do you write down the line? Right? Vertical passes through 3, 2, right? So what's the equation? Okay.
X equals 2?
X equals what?
Oh, sorry, 3.
X equals 3, right? X equals 3. Okay. And then horizontal, right? Horizontal, the y coordinate is fixed, right? Y equals 2. Slightly more complicated. This is about as complicated as you can get with such problems. L passes through 2 points, 2, 1, 5, 7. What's the line? You take half a minute and do it. Maybe 1 minute. Like if I were making an exam, maybe a lot, because 1 minute to do this problem.
What's the second one?
5, 7. I always cross my sevens.